I hope you've taken the time to watch the two short videos that reviews imaginary numbers. Imaginary numbers are going to be necessary in the next couple of sections and as we go through college algebra when we need to take the square root of a negative number. And so I've just posted some things from your textbook that simplifies those videos. The imaginary unit I is described as the square root of -1. So it's very important that you know that the square root of -1 is I, and I squared is -1. We're going to be solving quadratic equations in this lesson, and some of those answers come out to be complex numbers. Complex numbers are the numbers written in the form as A plus BI. A plus BI contains both a real part and an imaginary part. So this makes up the complex numbers. I've also copied from the textbook some basic powers of I. The biggest thing that you need to know is that I squared is equal to -1. So we will be using that in the next few weeks. Let's talk about solving quadratic equations. This is from section 1.5 in your textbook. A quadratic equation, as we know, is an equation written in the standard form ax squared plus bx plus c equals 0. A, b, and c have to be real numbers, and we know that a cannot be 0. If a was 0, then we would no longer have a quadratic. Quadratics are said to have a degree of 2. It is a second degree polynomial. The highest exponent in an equation tells the degree, and quadratic equations have a degree of 2. So we're going to learn all different types of ways to solve quadratic equations, and then you'll get to choose at one point what type that you prefer to use to solve. So we're going to start by solving quadratic equations by factoring. And to do that, we need to review the zero product principle. The zero product principle says that if I take the product of two algebraic expressions and my answer is 0, then at least one of those factors have to equal 0. So that's sort of common sense. If I take two things and I multiply together to get 0, then one of those answers has to give me 0. So if AB equals 0, then A is 0 or B is 0. And we're going to use that concept to solve by factoring. I've also written down the directions or the rules for solving a quadratic by factoring. If necessary, you're going to write the equation in standard form. In other words, it needs to be set equal to 0. Going back to the zero product principle, if two numbers equal 0, either the first number is 0 or the second number has to be 0. Common sense. The only way I can multiply two things and get 0 is if one of them happens to be 0. So using that, we're going to make sure that our equation is set equal to 0. We're going to factor completely, and then we're going to use that zero product principle to finish solving. And in every one of these, though I'm going to really concentrate on defining each type of how to solve, you should always check your answer. Let's look at some examples. Number 2 says solve the equation by factoring. So we're going to go through our factoring rules. This is a problem that does not have a greatest common factor. It is a trinomial, and it's an easy trinomial because there's no number in front of the x squared. So if I remember my rules of factoring, I'm going to set this up into two binomials. Using my sign rules, if my third term is positive, then I'm going to look to the left. They're both going to be whatever that sign is. The way that I break up x squared is to x times x. And with the easy trinomials, I'm looking for two numbers that multiplies together to give me my last term of 36, but adds together to give me my middle term of -13. So if I think about that, a -9 and a -4 will add together to give me -13, and when I multiply them, they're going to give me +36. So here's where the zero product principle comes in. Once we factor, I know that if this binomial multiplied by this binomial equals 0, then either x minus 4 has to equal 0 or x minus 9 has to equal 0. So I'm going to take both of those expressions. Once I've factored them, I'm going to set them equal to 0, and then I'm going to solve for x. So in this case, I would add 4 to both sides. X is 4. If I solve this one, I would add 9 to both sides. So x is 9. What we're going to be looking for with these quadratics, since it is a second degree polynomial, since the highest exponent is 2, I'm going to be looking for 2 answers. If you plugged 4 back into this equation, this would just be checking to make sure that my answers are correct. If I let x be negative 4, positive 4. Let me erase that. So we get times 4 plus 36 equals 0. We get 16 minus 52 plus 36. And we do get 0 equals 0. And if I do the same thing and I plugged 9 into the equation for x, I get 81 minus 117 plus 36. And again, you'll see that I do get a true statement in that problem as well. So my 2 answers are 4 and 9. All right, looking at number 10, the directions are the same. It says solve the equation by factoring. So be careful that you don't jump in there and just start trying to factor. I see that this has a greatest common factor, so I'm going to take out a 5x. So when I factor a 5x, I get x minus 4 left inside the parentheses. And I cannot factor anymore. X minus 4, the x is not squared, it's not cubed. Those are 2 terms. That's the only possibilities that I have when it's 2 terms. So I'm going to set each factored part equal to 0. So 5x equals 0. X minus 4 equals 0. So if I solve for 5x equals 0 and I divide both sides by 5, 0 divided by any number is 0. And in this side, I'm going to add 4 to both sides, and I come up with an answer of 4. So again, I have 2 answers, 4 and 0. And if we check those and plug those back into the original problem, I would see that both of those work. All right, so number 5, I went back and chose this one because it is a harder trinomial. There's no greatest common factor here, but I have 3 terms. So I have a trinomial, and because of that leading term having a coefficient, this makes it one of the tougher trinomials to factor. So remember from the review, I'm going to take the first term and the last term, and I'm going to multiply those together. So negative 10 times 6x squared gives me negative 60x squared. So I'm going to be looking for 2 numbers that multiplies together to give me negative 60x squared, but adds together to give me my middle term of 11x. Can you think of 2 numbers that would match that criteria? Now think about this. The third term is negative, so if I go back to my rules of trinomials, I know that one of those signs has to be positive and one of those signs has to be negative. That's the only way that I can multiply 2 numbers together and get a negative answer. So if we think about that, what about the factors of negative 4x and positive 15x? They multiply together to give me negative 60x squared, and they add together to give me 11x. If you have problems coming up with those factors, just go through the factors of negative 60. 1 times 60, 2 times 30, 3 times 20, then you come to 4 times 15. So what we're going to do is we're going to rewrite my problem as a grouping problem using these terms. And remember that I have a choice of which order that I write these numbers. So I'm going to write them with the negative first. That just makes it a little bit easier when I'm trying to group. I don't have to worry about that negative. So I'm going to group the first two terms together and the last two terms. I'm going to pull out a GCF. So in my first grouping, that would be 2x. And that leaves me with 3x minus 2. I'm going to factor out a 5 out of my second grouping. That also leaves me with 3x minus 2. And you see that I come up with the same thing inside parentheses. That is going to be my new GCF. So I'm factoring out 3x minus 2. And it leaves me with 2x plus 5. And to finish solving by factoring, I'm going to set each of those parts equal to 0. So 3x minus 2 equals 0. Let's add 2 to both sides. 0 plus 2 is 2. When I divide by 3, my first answer is going to be 2/3. The second answer I will get by setting 2x plus 5 equal to 0. And if you solve for x here, you're going to get negative 5/2. Subtract 5 from both sides and divide by 2. So that's one way that we can solve quadratics is by factoring. So let's talk about another way that we could solve quadratic equations. We can use something called the square root property. The square root property basically says that when I take the square root of a number, I get two answers. In other words, if I was taking the square root of 25, what two numbers could I square to get 25? Well, I could square 5 because 5 times 5 is 25, and I could also square negative 5 and get 25. Negative 5 times negative 5 is positive 25. So what we're reviewing here is that when I am solving for something that is squared and I take the square root of both sides, I always get plus minus. So let's talk about how to solve quadratics using the square root property. What you want to do is make sure that the squared part of the equation is by itself. Look at number 16. I want to get x squared by itself. So to do that, I'm going to divide both sides by 5. So that's going to cancel out. I get x squared equals 45 divided by 5, which is 9. So to solve something that is squared, I'm going to do the opposite, which is to take the square root. So I'm going to take the square root of both sides. The square root of x squared is x. What you have to remember when you take the square root of the right side, what two numbers am I squaring to get 9? It's going to be plus minus 3. That's the same thing as saying positive 3 and negative 3 is my answers. So remember with the square root property, please make sure that you get the part that is squared by itself. Let's look at another example. Solve the equation by the square root property. You can see here that my x squared is not by itself. So let's get that by itself first. I have to take care of this minus 1 before I can work with anything else. So I'm going to do the opposite. I'm going to add 1 to both sides. So now I have 3x squared equals 48. The x squared is still not by itself, so I'm going to divide both sides by 3. So this is going to cancel out and give me x squared equals 16. I've got the squared part by itself, so I'm going to take the square root of both sides. Don't forget, when I take the square root, it is plus minus. And what number do I square to get 16? That would be 4. If we look at 22, we see that I have a binomial squared, but the part that is squared is by itself. So the only thing I need to do is take the square root of both sides. When I take the square root of x squared, what number do I square to get x squared? I got x. So when I'm taking the square root of x minus 3 squared, what number do I square to get x minus 3 squared? It's x minus 3. So when I square x minus 3 squared, I'm just getting what's up under the radical. When I take the square root of 36, remember that is plus minus whatever number I squared to get 36. I have an extra step in this problem in that x is not solved for, so I need to add 3 to both sides. You always want to put this in front when you're adding it. These are going to cancel out. I've got that positive 3 that I'm adding, and you have to be able to simplify these because this actually represents two numbers. 3 plus or minus 6 means 3 plus 6, and it also means 3 minus 6. So my two answers ends up being positive 9 and negative 3. So be careful with things that you can simplify further. All right, we're also solving 24 by the square root property. What do you think I need to do first? Well, the part that's squared is not by itself. That's 3 times x plus 4 squared. So let's divide both sides by 3. That's going to give me x plus 4 squared, which equals 21 divided by 3, which is 7. Now I have the square part by itself, so I'm going to take the square root of both sides. When I take the square root of something that is squared, I just get that base. And I cannot simplify the square root of 7. There's no number that I could square to get 7. So I still, though, because I took the square root, it gives me the plus minus on the right side. So if I solve for x, I'm going to take the 4 to the other side. It's positive, so the opposite of adding 4 is to subtract 4. So we're going to leave our answer written like this as negative 4 plus or minus the square root of 7, but I want you to understand that those two answers are negative 4 plus the square root of 7, and the second answer is negative 4 minus the square root of 7. However, you can leave your answer in this form if you choose. All right, so the next problem, one more, solve the equation by the square root property, actually brings into review those imaginary numbers. When I go to take the square root of both sides, I get whatever's left inside the parentheses here. But over here, I can't take the square root of a negative number. As you watched in the review videos, there is no number that I can square to get a negative number. So I have to recall that the square root of negative 1 is I. So when I take the square root of that negative, that's with that 7, it's going to come out from up under the square root and becomes the letter I. 7 will stay up under the radical because I can't simplify the square root of 7. I have to keep going, though, and solve for x. And we always want to write this in the form of a complex number. Solving for x, to move 2 to the other side, the opposite of positive 2, is to subtract 2. And remember, when I take the square root of that I, it's still plus minus I square root of 7. Remember that the standard form of a complex number is the real part, that's the negative 2, plus the imaginary part. Again, this does represent two answers. It represents -2 plus I square root of 7, and it represents -2 minus I square root of 7. But you can leave your answer written in this form. The next way that we're going to solve quadratic equations is by completing the square. So I want you to remember that perfect square trinomials come in two different forms. One in which your middle term is positive, and one in which your middle term is negative. So if you'll recall when we were talking about factoring, if the third term is positive, we look to the left, and they're both going to be whatever that sign is. Same thing here. Third term is positive, I look to the left. If that left term is negative, then my sign is going to be negative here. The reason that we're covering this is because we can force these equations to be perfect squares, which allows us to take the square root. Completing the square says if x squared plus bx is a binomial, then if I take half of the middle term, that's what b over 2 means. If I take half of the middle term and then square it, I can write it as a perfect square trinomial, which can be written like that. What that's going to allow me to do is when I write it as a perfect square trinomial, I'm going to be able to take the square root like we were doing in the previous types of problems. So here are the directions for solving a quadratic by completing the square. Number one is you have to make sure that your leading coefficient is 1. If you have a number other than 1 in front of your x squared, you're going to have to divide all of the terms by that number. You have to get the coefficient of the first term to be 1. Next, you're going to isolate the variable on one side. So you want to make sure your constant term is on the right side. Then you're going to complete the square. You take half of the middle term, square it, and add it to both sides. This is going to result in a perfect square trinomial, which we will then use the square root property to solve for x. So let's put this into action. Solve each action by completing the square. So step 1, I'm going to check the number in front of the x squared. It is 1, so I'm good there. I'm going to rewrite this to skip a little space because the second step says that my constant has to be on the right side, and it is. But I'm going to skip a little space, which allows me to complete the square. I'm going to take half of the middle term. So I take the middle term and I multiply by 1/2. 6 times 1/2 is 3. You take half and you square that. So 3 squared is 9. And you're going to take that result and you're going to add it to both sides. Half of your middle term, half of 6 is 3. Square that, 3 squared is 9, and you add it to both sides. What you're forcing it to do is on the left side, it's going to become a perfect square trinomial. So how do I factor that? Third term is always going to be positive. I look to the left, it's going to carry that sign. What do I square to get x squared? X. What do I square to get 9? 3. A -8 and a +9 adds together to give me 1. I have forced this problem to be able to be a perfect square. Now I can take the square root of both sides. So the square root of x plus 3 squared is x plus 3. And remember, when I take the square root of 1, I get plus minus 1. So if I solve for x, I'm going to subtract 3 from both sides. So I get two answers. I get -3 plus 1, which gives me -2. And I get a second answer, which is -3 minus 1. My second answer would be -4. And I could check both of those by plugging them into the original equation. You would see that I would get a true statement. So let's try another one. My leading coefficient is 1. I'm going to write it just to add some more space to my third term so that I can complete the square. My constant's on the right side, so that's good. So I'm going to take half of the middle term. 1/2 of 4. Half of 4 gives me 2. Square that. 2 squared is 4, and you're going to add that to both sides. Half of your middle term, square it, and add it to both sides. This will always factor as a perfect square trinomial. This tells me my signs. X squared factors down into x, 4 factors down into 2, and on the right side, 12 plus 4 is 16. So let's take the square root of both sides. I get x plus 2 equals plus minus 4. Solving for x, I'm going to subtract 2 from both sides. And so I come up with -2 plus 4 as my first answer, and that ends up being +2. And then my next answer, I get -2 minus 4, which is -6. So remember, I should be coming up with 2 answers for all of these quadratics. All right, so I'm going to need a little bit of room for number 56. I see that my leading coefficient is 1, but my constant is not on the right side. So what I'm going to do is I'm going to take the -8 over. So since it's a -8, I'm really adding 8 to both sides. So 0 plus 8 gives me 8. I chose this problem specifically because students sometimes have a hard problem because when they go to take half of 7, it's not as easy to take half of 7 as it was in the previous problems where the numbers were even. So let's look at it this way. I'm taking 1/2 of 7. Of means multiply. So basically, I'm saying 1/2 times 7. So 1/2 times 7 is 7 halves. Half of 7 is 7 halves. And if I square that, I'm going to square my numerator and my denominator. So 7 to the second is 49. And 2 squared is 4. So our steps were to take half of the middle number, half of 7 is 7 halves, and square that, and you're going to add it to both sides. Now remember, this is always going to factor as a perfect square trinomial. This will always tell me my sign, so I'm going to have a positive here. And when we think back of perfect squares, think back of what you had to square to get 49 fourths. What number did you square to get 49? 7. What number did you square to get 4? 2. On the right side, I'm going to have to get a common denominator. So my common denominator would be 4 in order to add these together. 1 goes into 4 times. 4 times 8 is 32. So 32 fourths plus 49 fourths is going to give me 81 fourths. So let's see what we have now. Have x plus 7 halves squared still on the left side. and then I have 81/4 on the right side. But these problems are rigged. I'm going to be able to take the square root of both sides. So I get x plus 7/2 equals plus minus the square root of that numerator of 81 is 9, and the square root of 4 is 2. So solving for x, we're going to move 7/2 to the other side. Remember to always put it in front of the plus minus. It just makes it so much easier. So I get -7 plus 9 divided by 2. So this gives me 2/2. So my first answer is 1. And then I get -7 minus 9/2. So that's -16 divided by 2, which is -8. Our last problem that says solve by completing the square is one that has a number in front of the x squared, so we need to address that. If I have a number in front of that x squared, I'm going to have to divide every term by that coefficient. I got to get it set equal, or the leading coefficient to be 1. Zero divided by any number is 0. So now I'm going to take the constant term and I'm going to move it to the other side. So since it's negative, I'm going to add 10/3 to both sides. Now I'm going to have to make me some room to work this problem, so I'm going to erase the data from the previous problem. And let's complete the square. I'm going to take half of the middle term. That means to take the middle term and multiply by 1/2. So 5 times 1 is 5, 3 times 2 is 6. I take half, and I'm going to square that. So squaring the numerator, I get 25. If I square the denominator, I get 36. And I'm going to add that 25/36 to both sides. This will always factor into a perfect square. This tells me my sign. What number do I square to get 25? What number did I square to get 36? So x minus 5/6 squared. Let's get a common denominator over here of 36. 3 goes into 36 12 times. 12 times 10 is 120. So I have x minus 5/6 squared equals 145 over 36. So I'm going to take the square root of both sides. I get x minus 5/6 equals plus or minus, I'm taking the square root of 145 and the square root of 36, which is a perfect square. I wonder if 145 can be broken down, because anytime I have a number up under the square root that can be simplified, I need to simplify that. So I see the 145 ends in 5. So I know that it's divisible by 5. So when I think about the factors of 145, that is 5 times 29. Both of those numbers cannot be broken down. So that means that I'm not going to be able to break the square root of 145 down. So all I need to do is to solve for x. So since it's negative 5/6, I'm going to add 5/6 to both sides. So this is going to be my answer. 5 plus or minus the square root of 145 over 6. Now we could separate that as to two answers if we wanted to. 5 plus the square root of 145 over 6 and 5 minus the square root of 145 over 6. Just want you to really focus on the fact that you're getting two answers there. You know, I can't solve every quadratic by factoring because sometimes it's not factorable. I can solve every quadratic by completing the square. So if you look in your textbook, one thing that they do is they take the standard form of a quadratic and they complete the square. When you take the standard form of a quadratic and complete the square, you get the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. My point is that I can't always solve quadratics by factoring, but I can always solve them by completing the square. And because the quadratic formula is derived from completing the square, I can solve all quadratics using the quadratic formula. So if you're ever given a choice, know that the quadratic formula will always work. So what we want to do is we want to identify A, B, and C in all of these problems. Solve the equation using the quadratic formula. In number 66, A is the number in front of the x squared, so it's 1. B is the number in front of your x term, which in this case is 8. And C is your constant, so we have 12. And we're going to plug it into the formula. So x is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So let's plug it in. You can look at negative b as also being like the opposite of b. So negative 8 plus or minus 8 squared minus 4 times my a value, which is 1, times c, which is 12. All of that divided by 2 times a. Make sure that you do order of operations correctly, especially when you're working up under the square root. I'm going to do my exponent first, so x squared, or 8 squared, is 64. Then I'm going to multiply negative 4 times positive 1, that gives me negative 4. And negative 4 times 12 gives me negative 48. All of that over 2 times 1. So let's keep simplifying up under the radical. 64 minus 48 gives me 16. And 16 is a perfect square, so I get negative 8 plus or minus the square root of 16, which is 4, over 2. And I can divide these answers up. The first answer will be negative 8 plus 4 divided by 2. And the other answer is negative 8 minus 4 divided by 2. But keep going. Negative 8 plus 4 is negative 4. So my first answer ends up being negative 2. And the second answer, we get negative 12 divided by 2. So my last answer is negative 6. The biggest thing about using the quadratic formula is just to make sure that you do order of operations correctly, make sure you get your signs correct. So working one more example, if we worked 74 using the quadratic formula, in this case, A is 1, B would be negative 2, and C would be positive 17. So the formula is negative B. So negative 2 plus or minus the square root of B squared minus 4 times A times C, all of that divided by 2 times A. So negative 2, negative times negative gives me positive 2, plus or minus the square root of 4 4 times 1, or we can say negative 4 times 1 is negative 4. Negative 4 times 17 is negative 68. So we get 2 plus or minus the square root of negative 64 over 2. So I just want to remind you about taking the square root of a negative number. That is the square root of negative 1, which is I. So we get 2 plus or minus the square root of 64 is 8. The square root of that negative is I. And I'm dividing that by 2. And so really what I'm doing is I'm factoring a 2 out of the top. And that doesn't look like what I'm trying to write, but it's 1. If I factor a 2 out, I get 1 plus or minus 4i over 2. The reason that I have to factor is that I cannot cross cancel between a plus minus, so I'm actually factoring, but my two answers comes up to be 1 plus 4i and 1 minus 4i. You do need to know the quadratic formula, and we can use that to solve any quadratics. The last thing I want to talk about is the discriminant. The discriminant is what we call b squared minus 4ac. That is the part of the quadratic formula that appears up under the radical sign. And the discriminant is special because it tells me the number and type of solutions. If you plug in the discriminant and your answer ends up being positive, if the discriminant is positive, this means that you have two different or two unequal real solutions. And these solutions are your x-intercepts. So by knowing the discriminant, you know what type of answers you should come up with. If your discriminant equals 0, then what you're actually going to have is you're going to have one solution. It's really a repeated solution. It's like getting the answer x equals 3 and x equals 3 when you factor. So if the discriminant equals 0, you have one solution. It is a real number. If when you get the discriminant and it's a negative number, if your discriminant is negative, it means that you have two imaginary solutions. Remember what we said about imaginary numbers? They are real numbers. Imaginary is not supposedly the best name for it, but our solutions are two complex conjugates, such as 3 plus or minus I square root of 3. That would be an example of a solution. Again, there are no real solution. They're two imaginary. They're the complex conjugates. All right, so they asked me in the next part to find the discriminant first of all, and then determine the number and types of solutions. Remember, I don't have to do the whole quadratic. I'm just evaluating b squared minus 4ac. So in this problem, b would be negative 4. My a would be the number in front of the x squared, which is 1. And my c is negative 5. And we're just going to plug that in. Negative 4 squared minus 4 times 1 times c. Negative 4 squared is positive 16. And do your order of operations correctly. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20. The discriminant is 36. Now, because the number is positive, that means that I have two real solutions. And if I even wanted to be more specific, I would say two unequal or two different real solutions. Again, we're not solving here. We're just trying to find out what type of solutions we would get if we solved. Using the discriminant in 79, b squared minus 4ac. b in this problem is negative 2. Times 4 times a, which is 1, times c, which is 1. I get positive 4 minus 4, which in this case is 0. So if my discriminant equals 0, my answer has one real solution. And we know that that real solution is a repeated solution, like we saw in the previous example. If x was 3, really we got x equals 3 and x equals 3, but one real solution. It's going to cross the x-axis at one intercept. That's going to be my one solution. Before I do number 80, which we're still computing the discriminant, remember, you must have that equation set equal to 0. It must be in standard form. So I'm going to move 2x to the other side. So it's positive, I'm going to subtract it. And I'm going to move -1 to the other side by adding. Get your equation set equal to 0 before you determine the discriminant. Now I can do b squared minus 4ac. So -2 squared minus 4 times, this time a is 3. My c value is +1. I get 4 minus 12, which is -8. So my discriminant is -8. That means that I have no real solutions. And really what I have is 2 imaginary solutions. In other words, they're going to be in the form of a plus or minus bi.